Hey folks, welcome back! Continuing on with our beginner series, today we're going to be talking about a brand new topic, and that topic is raycasting. Raycasting is a really common concept that we apply to a bunch of different situations in 3D game design, and it's useful because once you've learned to do it, you can use it to build all kinds of things in games. For example, have you ever played a game where you had to place objects on uneven terrain, and you had a UI indicator that looked something like this when you were trying to place the object on the ground and find a valid location? That system used raycasting. Have you ever played a first-person game where you had to look at a bunch of objects up close like this and see them light up when you got close to indicate that you could pick them up or interact with them in some way? That's raycasting. Or maybe you've played a game like Overwatch where some heroes, for example Soldier 76, instantly hit whatever their gun is aiming for when they hit the fire button. This is called hit scan in a lot of first-person shooter communities, and hit scan is based on raycasting. In other words, there's no one obvious application for raycasting. It's a tool to put in your game development toolbox. And if you learn how to do it and you learn how it works, then in some situations you might think to yourself, you know what? I could do this with a raycast. And that's what we're going to learn today. Today we're going to be using raycasting to build a simple system that lets you pick up and drop 3D objects on the floor. It'll be like a very, very low budget Minecraft. So when we start to talk about raycasting, a lot of people naturally want to go break down, hey, what is a ray in physics? Let's start there. And that's great. The only problem is I didn't do so great in high school physics, and I haven't taken it since because it turns out you don't need physics or math to be a successful game developer. So I'm going to explain it to you in a way that's even easier to understand. This is a laser pointer toy. I use it to play with my cats. If you've ever had a cat yourself or know anybody who does have a pet cat, then you are very familiar with what a toy like this does. It has a little button on it, and when I press the button and hold, it fires out a little ray of light, like this. And of course, because it's a beam of light, it doesn't have a fixed length. As you can see, I'm shining it on the wall behind me. Its length grows as the length of the ray grows. In addition to having a potentially infinitely long length, the ray also has some other properties. For example, it has an impact point, which is wherever it's actually hitting in the world. That impact point would be returned as a vector, which is just, as we've seen before, a 3D position in space, an X, Y, and a Z. In most game engines, we also get some other information back along with the impact point, such as what was the actual object that got hit by the raycast? What type of an object was it? In a first-person game, the most common application of this is just to determine what the player's looking at. We fire a raycast out from the center of the camera, and we determine whatever we hit with that raycast. So it looks a little bit like this. The laser pointer is strapped to the front of the player's face. It's important to note too that even though the general concept in game development is called raycasting, and that this is what it's called in Unity, in UE4 it's called a line trace. So it's the exact same concept, all the same outcomes, all the same data, just goes by a different name in the Unreal Engine. So that's the core of what we're going to be using to build our pick up and drop system today. Without further ado, let's hop back in and get started. So by popular request, I have moved my Unreal to my lower resolution monitor for those of you who are on mobile and are trying to follow along on teeny tiny screens. Hopefully this helps. Let me know in the comments if this actually is an improvement for you or not. So we're going to go through a few steps today. The first thing that we're going to do is to create a pick-uppable actor class, which we can then use as the parent class for any objects that we might want to make pick-uppable in our world today. Secondly, we're going to use the input things that we learned in our last video to set up a brand new input action, which can be used to fire a ray out from the player's face, check what we hit, and get the results of that collision. Then, once we've gotten the results of the raycast, if it turns out that we hit something that we can actually pick up and grab, we will do that. We will parent it to the player so that the player actually appears to be physically carrying it around when they move. And then we'll create another input action which lets the player drop the object when they no longer want to be holding it anymore. At that point, when they drop the object, we're going to be doing a raycast from the sky to the ground to pick an appropriate landing point for the object so that it actually lands on the floor and doesn't just drop or fall out of the player's hands. So let's do the hardest part first, and we're going to go ahead and create that pickup object actor class, as I like to call it. So let's right click down here, and we're going to create a new blueprint class of type actor, and we're going to call that a pickup object. Go ahead and hit enter. We're going to go into this. And for the most part, this is actually going to be an empty class. We're not going to have very much in here. This is mostly just going to serve as kind of an empty parent class for any other type of pick-uppable thing we might want in the future. So for example, let's say that like you're making a hidden object game and there's a bunch of different types of objects you could have. you would probably all want them to be like pick-uppable. And when you are raycasting, you don't want to check that the actor is any of 274 different actor types. You probably want to check that it's of a certain parent class, regardless of what that child class might be, because that child class could be like vase or like murder weapon or clue or, you know, cube or any other number of things. But if we just have this one parent class that kind of like supersedes all of that, then we only have to check that the parent class is returned. And from this parent class, we can also write any of the code that is going to be more generically extensible to all of the children that are part of the class. We learned this in our, I think, second or third lesson. So let's start by just writing a generic function that gets called when this actor is hit by a raycast. In other words, we want to pick up this object. So let's just start here by writing a generic event that is going to get called whenever this thing is the target of a valid raycast out of the player's face. In other words, the player is expressing, hey, I found a pickup object and I want to do the pickup on that object. We can't actually do the full pickup code yet because we need to be able to like parent that object to the player, and that's going to require us to set some stuff up on the player first. So for now, let's go to the event graph here. And let's just add a quick stub event just to have something here. Type in custom event. We're going to add a custom event and we're going to call this do pickup. And then on the do pickup, for now, we're just going to print some text. So we're going to do a print string, and we're going to say I got picked up as the string. And that will show up if the pickup successfully happens on the player side of things. So for now, let's just set this up and let's back up out of here. Maybe if you want, now what we can do is we can actually go back out to the map and we can create some children that would inherit from this pickup object. So let's do that now. Let's create a blueprint class. And what we're going to do here is actually, when it says pick a parent class, now, because we've established this pickup object parent class, this is not going to be of type actor. We're going to be able to search in our classes down here. If you saw, I actually expanded this little arrow down here to get this menu. You can type in pickup object, and you see it shows up here in the little hierarchy because pickup object is itself a child class of actor. And that's going to be our new parent class. So if we use this pickup object as our parent class, let's just call this pickup cube because it's sort of more specific than the generic pickup object. And we're going to add a component here that is just like a cube mesh. And we're going to make that's like a size 1 cube. That seems great. I'm going to make it pink. I'm actually reusing I think I'm reusing the material from the door tutorial, which like, okay, cool. I love it. Fine. Unless that material's bad. Ooh, apparently that material's bad. Let's make a different material. How about, ooh, what is this? Oh, rainbow. I love it. Temp materials galore. Ground moss. Don't know what that is. I love it. It's going to be like a green spongy cube. I am like really fishing around in the garbage here. And that should be good to go. So we actually, you can see up here in the top right, if you look at the top right of your screen, the parent class is type pickup object. So it automatically has this do pickup custom event that we have here can also be called on this child actor, and you'll see how in just a moment. So let's save that. Let's go out to our map and let's place some of those cubes around in the world. We're just gonna like put them around like this. They'll come in handy in a second. Let's put like 3 of them in the world for now and call it a day. So now to get even crazier, we are going to put a component in the player pawn that actually is just like a little space in air in front of the pawn's camera. And what we're going to do is when we actually like complete the pickup of this object, we're going to parent it to that component, which is sitting in front of the player's face, so that it looks like the player is like carrying this cube. Because we're in a first-person game, it will sort of appear that if the object is like kind of loosely hovering in the frame of view of the camera, that we're like holding it. So it's a very poor man's imitation of a pickup system, but this should be sufficient for now. So let's find our pawn. We have this tutorial pawn that we have set up in the previous tutorial. And if we go to the viewport here, you'll see that there's this little like arrow which represents kind of the navel of our pawn. We are going to add in a scene component here. So add a component, type in scene, and you'll find this component here. We haven't added a scene component before. A scene component in UE4 is kind of just it's a very vanilla component that you can use to do a lot of things that involve 3D space. So all it really is it has like a transform. It has like an X, Y, and a Z location, and you can attach things to it. Doesn't have any rendering, doesn't have any collision. It's just kind of, you'll even see in the description here that is showing up the white box. It says useful as a dummy component in the hierarchy to offset others. And that's what we're trying to do. We're trying to parent this cube to the player, and we're trying to offset it so that it's like in front of the player's face. So let's add this scene component in, and we'll just call this pickup object attach point so it's super clear. Hit enter. And this is a good position for it in the hierarchy, but if we want it to be even better, we'd probably want to parent it to the mesh. That is the mesh being like the player's physical body 3D mesh in this situation, which of course we don't have one because we deleted it in that player pawn tutorial. But if we did have like a real player body, like this is where it would go. So we probably want it to be parented to that, since it's like we're dealing with the realm of the physical here, like actually looking like you're picking up an object. So let's put this pickup object under the mesh. And then I'm just going to kind of like drag it. I'm going to drag it like a little bit out here. You know, we can adjust it later so that it looks perfect. But right now it looks like it's right in front of the camera. It's like right at the front of the collision capsule for the player. That's a really good location. That'll just make sure that it's like far enough out that you can actually see it to make sure that your code is working. So let's save that for now. And now we're going to go back to our pickup object and write the rest of the code. So now we're going to jump a third time, and bear with me here. I know this is a lot of like jumping around from piece to piece, but it will make sense why we did this in a second, I hope. So now we want to actually hook up the input to allow the player to even press the key that would start the raycast so that we can build all of that code next. So let's go into our tutorial player controller. And actually, before we even do that, we're going to set up the input action event itself. So like, just make sure you have this tutorial player controller open. But let's go here into edit and project settings, and that'll chug for a second. And then it will open up your project settings window here. We did this last time, but let's go down to input, and we are going to set up an action mapping. See, we've still got all of our stuff in here from the gardening tutorial. I'm going to add another one, actually two more. One is pick up object, and I'm going to bind that to, how about like F? F is a very common one, F to interact in a lot of games. So let's do that. And then I'll do one more. That one's going to be called drop object, and that is going to be called, we're going to put that on G. We could also put that on F. We could make that like a binary, like, hey, if you have an object currently picked up, you can drop it again. That will be part of the homework assignment, is to try and go back and do that. It involves some simple Boolean work, but I stripped that out of this tutorial because I figured that like level of complexity is like a slight addition, but we don't need to cover that here. So let's X out of this. Now that we have those keys set up, we're going to go back to the tutorial player controller. And if we right click here and we try and pull off pick up object, we should actually see our input action show up here. And just for ease, let's go ahead and pull out the drop object one here as well. So here's the weird part. We now have these actual input actions in the controller, and we can fire them when the player presses the appropriate key. But we need some way to actually talk to the camera that is on, as you can see here, the player pawn. In other words, you'll see this big chunky blue camera here. We don't actually have access to a camera on the controller. All the controller does is handle some of the high level sort of input code and processing, but it needs to go through its possessed pawn to get the components that might be on that pawn and actually talk to them. So we need to kind of like tunnel through the pawn, which then is going to actually call to the pickup object and tell it to handle the pickup. So it's this little weird funnel where we go through the controller to the pawn, to the pickup object, back to the pawn, and then back to the controller. So When the controller possesses the pawn, which happens, by the way, at the start of the game by default, we get an event that is called onPossess. And so to make sure that we're getting just one onPossess event here, if, for example, you still have, just make sure, like, type up here tutorial. And if you see any instances of the tutorial pawn in your scene, just make sure to delete them. I think there was like a pawn left in there maybe at the end of our last lesson. So just to make sure you don't have any extras floating around, just make sure they're not there. They will be spawned automatically, as you can see at runtime by the game. So we don't need to actually have them sitting in the scene. So go back to your tutorial player controller here. We're going to right click and we are going to type in onPossess. And you should see event onPossess show up here. This is an event that we inherited again from our parent class. If you see in the top right here, the parent class is player controller, which goes into C++. And that onPossess event, if you set a breakpoint here with F9 and then compile and hit play, you'll see that it gets called instantly. It's the first thing that gets called whenever this controller and this pawn start running, because that possession event happens at the start of the game. So that's good, because what that does is it gives us back some information about the pawn that we just possessed. So for example, we can now cast that to tutorial pawn, which of course we have to cast things in Blueprint in order to get specific functions or components on that object. So now, as the tutorial pawn, because we've done the cast, we can get the camera. I think it's called, if we scroll down to the bottom here, on my character, it says get first person camera. So now we have access to the first person camera here. And we can actually, just to make sure that that's working, let's get the world location, and we're actually just gonna like print string that. Here, actually you're gonna not wanna drag off from that because by default, the print string only wants to take a string, but you can make it take a vector and it will do the conversion automatically. Just don't do that by dragging off from the yellow vector because the node doesn't like to be made to do that by default. So let's compile, hit save. And now when we possess, you should actually see in the top left of your screen, when you hit play, you'll see that there's actually this little string in the left that should show the location of the camera, and it should not be 000. Like that should actually be a location in the world. So just verify that that's working real quick. We can now delete all of this. We just really want this node here. So now what we need to do is we need to store off this first person camera reference so that whenever the player hits the button to try and pick up an object and we actually want to fire our raycast, we don't have to like re-go and get the player camera every single time. We have this consistent reference to it. So over here on the left, let's set up a new variable. We're going to call this player cam ref, just to make it super clear what it is. And you can see this variable is going to be of type first person camera. That in that little white box to the right, that thing on the bottom, that camera component object reference, that is the type of the variable here. So it is camera component object reference. I misspoke. So let's go up here and type in camera component, and you'll see here camera component object reference. There we go. Bingo. We want to set that variable of type camera component, and we are now going to drag that off here, set, we're gonna drag it in here, and we can hook this up here. You could also just drag it off and type set player cam ref, and it will also let you do that because they are of the same type. So it's just whatever works best for you and your personal workflow preferences, but both of those things will work. So now we've set this player camera reference. So what we're doing is when the game starts, we possess our pawn and we make sure that it is the right type of pawn that we want to be spawning, which it is because that's what it's set to be in our current game mode. And then as the tutorial pawn, we get its camera and then we just store off a reference to it. So now we get to do the raycasting part of this. So now just to start, we're gonna first, before we actually do the raycast, we're gonna just draw a debug line and make sure that when we raycast, we're doing it in the right direction and in the way that we think that we should be raycasting. Because normally raycasts are invisible, so you can't see them. So in UE4, I like to just have a debug line that kind of like shows me what I'm theoretically raycasting to, so that I make sure that I've got everything plugged in correctly. So when we press this input action pickup object, we're going to want to get a player cam reference here, and we're going to want to get world transform. on that player camera, because again, we're raycasting from the camera. So we get this transform. If we split that up, it'll come back as a location, rotation, and scale. And what we're going to do is we're going to draw debug line, and we'll find a node right here called draw debug line. So now we need to feed it some information. As you can see, there's the line start, there's the line end. Again, these are vectors, these are points in space, and this is exactly the same information that we will want to plug into our inevitable raycast to give the ray a start and an end location. We can also pick a color. I'm going to pick something that will really pop and show up, like hot pink. We can pick a duration for the debug line. I'm going to just make it like long, just so we can make sure that we can see it. And I'll give it a thickness of 1, a duration of 4 seconds. And then we need to plug in some information. So the start location should just be the location of the camera. That part we know. But what's the end location? That's the hard part. So for the end location here, what we want to do is we want to take the rotation of the camera. In other words, it's not just about like the starting position. We also want to like make sure that if the camera is rotated, we're taking into account the directionality of the line that we want. And so we want to get off that vector, but then we also want to make it longer. In other words, we need to make sure that the endpoint of the line is quite a fair distance away from the start location of the line or the ray, so that we're actually getting something that like has moved in space. So with raycasting, generally speaking, you'll be multiplying by quite a high number because you want that line to be sort of like just go off infinitely in a direction. And we can't feed it infinite information, but we can feed it a sufficiently large number that it approximates what an infinitely long ray in that direction would be. So let's take the rotation, and we're actually going to take that rotator. So let's take that rotation, and we're going to get that forward vector of whatever that direction is off in space. So if the camera's like rotated this way, it would be off this way. If the camera's rotated this way, the forward vector would be like this. That forward vector is just a continual straight line in space. And we are going to multiply that by the length that we would, like this line to go. So let's make it a sufficiently large number. I like 10,000. 10,000 seems to cover most cases. And if we just do that and we hit compile and we go into the game and we hit F, you should now see that when you move, you can actually see that line. And I've got this little red reticle in the center of my screen here. If I look at the corner of this wall and I hit F and I walk away, as you can see, actually we have raycasted from the camera to that corner. If I look at this cube and I hit F, well, there you go. We're cutting right through the center of that cube. And so this is what our raycast actually looks like practically, right? And in any first-person game where you are raycasting, this is what it looks like behind the scenes. We're casting this invisible line, and we're using it to determine what we're looking at. So this is nice because we can actually see our raycast functioning in practice. So that's great. Let's back out and let's do the real thing now. So when we go to actually put in our raycast, we're going to drag off from here and we're going to type in line trace. And you'll see there's a number of different line traces that show up here. You can line trace all kinds of things. There are even like AR, there's some kind of other libraries like Lumen AR that lets you do this if you were building an augmented reality app, which we're not. So I think you could safely ignore a bunch of these like complex types of line traces. You can actually hover over them and read the descriptions if you would like. For now, we're just going to pick a line trace for objects, which is very simple. This is the one that that a lot of developers use most commonly, myself included. So we're going to drag off from this in the object types, and we're going to make an array of object types that we're looking for. And when we say object types, this is not the same as actor types. We are not actually trying to filter down by like specific types of actors that we're looking for. What we're trying to do is just kind of look at broad categories of objects that UE4 has and see if we can like filter out some types that we definitely don't want to hit when we line trace. Because keep in mind, just like this laser pointer, The ray sort of like has things that it will collide with in the world and things that it may not, you know, in the same way that, like, for example, maybe a laser pointer goes through glass, like it doesn't collide with glass. If you shine this laser pointer through glass, you will see it hitting things that are on the other side of the glass, because glass is not considered to be like a valid, you know, collision channel that we care about when we are line tracing a cat laser pointer. So and the object types here, if you expand this drop down, you'll see that we have world static, world dynamic, pawn, physics, body, vehicle, destructible, and projectile. Several of these are pretty self-explanatory. So like a vehicle is a vehicle type. We don't have any vehicles yet. That's probably like an advanced tutorial series topic. Destructible, same deal, projectile. We've done projectiles before. That might be like, hey, if I like want to play a game where you can fire balls out of a gun and I want balls to hit other balls in the air, maybe those projectiles collide with other projectiles. We're not doing that today. Pawn and physics, body, again, those are fairly self-explanatory as well. Today, mostly what we care about is world dynamic, because the things that we are adding to the world, these cubes, these actors, they are by default of type world dynamic. So let's make sure that we are looking for them when we are raycasting. It's generally a good rule of thumb, too, that anything that's not explicitly marked as like a static object, which is something that designers and engineers and artists will often do to pieces of the world, so that we're not doing things like recalculating shadows on them every second. Static is a term that just means this doesn't change. If it's not explicitly been marked as like a world static object, it's safe to say that the majority of the time, the things that you're going to be placing in the world are going to be of type world dynamic. This is the most common bucket for a lot of things that designers will work with in games, because we are writing rule sets about things that the player does and places and spawns in the world. So this just tends to be the case. So we are going to be line tracing for a world dynamic object. And again, because we already did the work to calculate what we want here, we can actually just plug in those same values to the start and end of this line trace for objects. And now we get this out hit, properties of the trace hit. Aha, this is what we want. So we're going to drag off from this, and we're going to go down to here. You can actually see it's here by default, break hit result. And it says it extracts data from a hit result. You will see here all of the juicy information that a raycast can give us. We can see, hey, was there a blocking hit? Did this raycast get blocked by something or not? True if the, you know, this initial overlap. True if the hit started in an initial overlap. Time. How long did it take for this trace to hit something? Distance. How far away is the impact point? The location. So there's a bunch of information here. Like, hey, even like physics material. So for example, like, hey, if we hit a wall with our bullet, can we check the physics material of the wall so that we can play the appropriate sound effect for whatever it was that we hit? Those are super common. Bone name. Hey, are we making a zombie game where like if we hit the zombie's leg, we want to like break that specific bone or do something to the animation on that side of the thing's body? Yes, we can by getting the bone name. So UV4 gives us so many different types of things that we can do here. But all we care about here is the hit actor. So for now, we're going to do something super destructive. We're going to cast that to a pickup object, and if it's true, we're going to destroy that object, just temporarily, just to do something very dramatic and make sure that this is working. So cast to pickup object, not cube, because that's our child actor, but the parent class. We're going to cast a pickup object, and if we succeed, we're going to destroy actor. So let's do that. Let's compile that, and let's see how that goes. So we're going to hit play on that. We are going to look at our cube, hit F. It's gone. Bam. Look at that. We pierced it with our trace. Ha ha ha. And you'll see that if we hit F on a bunch of other things, because they are not of type world dynamic, this is all marked as static geometry, nothing happens. So it only works with things that are world dynamic and that are also of actor type pickupable object, which is great because that means that we can designate things that should be picked up in this world and things that shouldn't be. Okay, but we don't actually want to destroy this object. We want to parent it to this this component that we created in our player pawn, which is this pickup object attach point that's like nice and in front of the camera. So let's get rid of this destroy actor node. And what we're actually going to do is we are going to attach actor to component. And we want to just get the component. But here's the problem. We are in the controller still. So we need to get access to that thing that is on the player pawn. So what we can do is right click here and we can get controlled pawn. If you type in get controlled, you will see this pop up here. Return the pawn that is currently controlled by this player controller. Bam, easy. So we're going to do that. Make sure to cast to tutorial pawn. And there's actually like one more step missing here, which is that we can't attach this to component because you can see this is not a component. This is the entire tutorial pawn actor. So we need to just get the component that we want to attach this pickup object to, which is, we named it the pickup object attach point. So let's get pickup object attach point. And if you scroll down here, you'll see that here. That is what we are attaching to. So we should now have something like this. Basically, we're casting a pickup object, then we get the controlled pawn and cast to tutorial pawn, then we get the component, and then we do the attachment. Make sure that you have this properly in order, or you're either going to see like grayed out nodes that don't work, or you're just going to see some really weird behavior. Order of operation is super important in Blueprint. So for the location rule, let's keep the world location. We don't necessarily want relative location. We do want it to just like stay where it is in the world and not automatically try to like adopt some sub position of the player just yet. Let's just see what this looks like. So let's hit save. Let's play. And then go ahead and try to pick up your cube. Hit F. Nothing happens. Ooh. Oh. It's getting, I mean, it's attached, but it's getting dragged along the floor. It's looking pretty weird. Why is this happening? This is happening because although we literally attached this actor to the player, and in fact to that scene component that we have, we didn't change the position of the actor when we did that. Normally in games, when you like pick up an object, you actually move the object to the location of like the place that you want it to be held by the player. So we are going to do that. So let's, after the attach, we're going to actually set the world location for this actor. And we're going to make that world location the same as the pickup object attach points location. So we're going to get world location on that pickup object attach point. And we will do that. So by the way, this is like super messy. There's just a bunch of noodle action happening here. So I'm just gonna like double click here and drag off a couple of little nodes here just to make this like very slightly cleaner and less annoying. I hate it when the noodles overlap. I really would prefer that they didn't. So let's clean this up. All right, we're looking good. So now let's see what happens here. Hit F. Now all of a sudden, ooh, look at that. Okay, so it is snapped to our player, but something really weird is gonna happen here. So I'm hitting forward to walk, and I am zooming away backwards from this cube. This is the weirdest thing I've ever seen. What's happening? Well, guess what? This cube has collision turned on. And every time I try to walk forward, my player is now colliding with the cube that I currently am holding, and that collision is sending me backwards. So now I need to actually do the right thing and turn off the collision on this cube when I pick it up. Should be easy. So if you like look at our cube, and you look at the cube mesh here itself that we added, scroll down here on the right and look at the collision channel that we're in. You'll see that the collision preset is block all dynamic. Ooh, what is that? World dynamic object that blocks all actors by default. So that's not good. So why don't we, basically what we want to do, we do generally like that the cube has this collision setting on it because it does lovely things like prevent the cube from falling through the floor. If gravity is enabled, for example. The problem is that we really don't want it to like have collision at the moment that we're holding it. So we're just going to turn it off then. So for this pickup object, what we're going to do is I'm actually going to drag this off here. You know what? Actually, even better. Let's store off the object that we currently have held. This is Galaxy Brain here, and we're going to call this. It's of type pickup object, not pickup cube, on our parent class. So we're going to right here, we're going to set currently held object to be the value of this thing that we got, so that now we have access to it over here. So on this currently held object, let's set actor enable collision, and we're going to turn that off. Let's see how we fare. So now, as you can see, we can pick up the actor, and we can move around with it because we have turned off collision on it. I mean, it's a little high though, like it blocks view when I'm actually moving around with it, and that's not super ideal. So let's back out here, and let's say we want to do some adjustment like that. We can actually look at our pickup object detach point, and we can just bump that down a little bit lower, hit save on that. And now if you try again, you should actually see it's a little bit lower, so I can actually see where I'm going now. Great, yay. But now we actually might want to build the code that lets us put this actor down, since now it looks like we can't pick up anything else, and we also can't drop this actor. We're trapped with it for life. Probably not a very fun game, so let's add that part. So let's start with like a really simple detach, and just see where that puts us. So we're going to go to this input action drop object over here, and when we press it, we're just going to do the opposite of what we did when we attached this actor, and we're just going to detach it. And in fact, we have a reference to the currently held object already, so that should make this easy. Let's just detach it from actor, and let's of course we want it to keep its world position, and that looks good. So let's do that when we hit drop object, which I think I bound to G. And we'll see how that goes. So hit F, pick it up, take it over here, hit G. It stays in space. I love it. There's only one problem. It's floating in the air, because when we picked it up, we parented it to a component that was off the ground. It was in front of the player, and it took on a new Z height, but now it's floating. So less than ideal. This will work as a start, but we probably want some way to make sure that this thing is on the ground, even if the ground is like on a slope or something. Why don't we use a raycast? What we can do is we can raycast from the sky to the ground and find where the ray collides with the ground plane. And once we have found that collision point, we know, you know what, that's the right place for this cube to go. So let's make that happen. So now we're going to set up a different type of raycast. We're going to set up a raycast that is that basically is from the sky to the ground, that finds a valid location for us to drop off this object. So in order to do that, we're going to need to do some things. Probably whenever we have an object picked up is when we want to be in this mode. So we don't want to be constantly looking for a place to drop off this actor. We probably only want to do it sometimes, and that sometimes is like, hey, we have something picked up right now. So let's add in a tick here. Everyone's favorite highly performant function. And if this is valid, basically, then we want to do something. And if it's not, then we don't. So what we're going to do is we're going to start off by getting the forward vector of the control pawn. So once again, we could probably stand to store off the tutorial pawn and just have a reference to the pawn in the same way that we have a reference to the player camera. So let's do that now. Let's call this player pawn, or even really like active tutorial player pawn, just to make it super clear. This is of type tutorial pawn. And on possess, we are going to set active tutorial player pawn, geez, that's a mouthful, so that we have a reference to it, which means that now when we're down here on the tick, we don't have to like get that pawn every tick, which is like very, very expensive. So probably let's just get the forward vector of the capsule component. Yeah, and really we could do capsule component is like the top level component in the pawn. So it's probably just going to end up taking this this little arrow forward vector here out of the belly button, which is fine because we're going to do some calculations on it. So let's get the forward vector of the capsule component just to start. In order to have it sort of spread out from the player a little bit, we probably want to multiply this vector by a certain distance. I like 500. I think that's probably like a good safe distance. You can make it a little bit bigger if you just like really want to make sure that you can see this ray. Start with 1,000 or something like that to start. And at this point, I'm actually just gonna like stack some of these components a little bit just to kind of make sure that we're working in an understandable space that we can see. The other thing too is that we actually need to add 2 of these vectors. So we actually need to add this forward vector to the current location of the player, because just the forward vector itself is not enough information to actually determine like the starting location of this ray. So let's also get the world location of the capsule component. And then together we are going to add these 2 rays together. So let's go ahead and just do a vector plus vector, and then we'll combine them. And what we actually want to do here probably, because we're going to be manipulating this position to kind of like, you know, get a plus and a minus on it to make sure that we are raycasting straight from the sky, we probably just want to like store this off to a variable. Intended placement position, I think that's a nice name for it. And we can set this intended placement position. But actually, here's the deal. We don't want to set all of the intended placement position because we are going to want to fudge with the z a little bit, because the z again is our variable that determines the height of something. And because we're raycasting vertically from up high to down low, we will want to be modifying just the z. The x and the y are fine. So let's drag this off as a set. And we're going to right click and split struct that pin. And then we're going to drag the x and the y in here, but not the z yet. So let's hook that up here and get that as part of the flow. And actually, if we want to see this in action, all we have to do now is give it a z height and a z low point. So we're gonna like break these vectors. We're gonna do it twice because we're gonna make 2. So I'm gonna Control C and Control V to just paste that node twice. And then we have an X, Y, and a Z here. What we're gonna do is we are going to, let's do a debug line draw. And we're going to right click here and type a make vector, because we're about to make a couple of vectors and then plug those suckers in right here. Again, Control C, Control V to copy paste. And the X and the Y is fine, but the Z is going to be a little bit different. For the first Z location, we want this to be up high. So let's say like, 3,000 is good. That's quite high. And then we'll make this one a negative 3,000. It'll be quite low. So we're not hooking up the Z here. We're setting that Z custom. Let's make the line color something really obvious and different from the pink, so like blue. We'll make the duration 1 second. We'll make the thickness 1. We'll hit compile. We'll hit save. And then I want you to hit play and try picking up a cube. And you should see this blue line appears. And in fact, there's a new one every tick. So there's actually, it's like a curtain of blue lines, but it is trying to place that line where it thinks this cube is going to be dropped. So it's actually a little bit hard to see. So what we might want to do is like go into the pawn and even move that that pickup attach point even lower. I'm going to do that just so I can actually see more easily over the top of these huge cubes that I'm picking up. But you can see that that location is like kind of trailing me a little bit as I move around. So it looks like it's pretty far out, but I can see exactly where it is. So that's good. That's a good sign that our math is checking out and that we're seeing the results that we would want to see here. So let's go back into our controller here. And what we're going to do now is we're going to do the exact same thing. We're going to do a line trace for objects. And just like we did before, we're going to break this out into object types, make array, and this time we're looking for world static or world dynamic, because we want to be able to place these cubes on top of not just the floor, but also potentially other cubes, right? Like if we only look for world static, then we can only place it on static geometry. But we also might want to just stack some cubes. Like that's also totally okay. So let's feed in those exact same values. And if there was a hit, because, you know, maybe we're like doing this over a, you know, spot in the sky and there is no hit. So if there was a hit, then let's break this hit result and we will get the impact point. And what we want to do when we drop this object and detach it is we actually will want to get the location that we are going to drop it off at. So let's take this code. It's getting a little crowded. I'm gonna bump it down here just so it's easy. And so let's store off this intended placement position. We've already started to store it a little bit over here, but what I'm gonna do is just complete that here. So we're gonna set that here to the impact point. And now we're gonna save it off for good. And actually we probably don't need to have this set over here because we're gonna be just resetting it again instantly if we did find a valid impact point. But it kind of doesn't matter. We can reuse it in a couple of different locations here. And now what we should do once we've set the value of where we would like to place it is when we drop the object, we should set world location on that object to be, bump that up, bump down here, set that to be our intended placement position. So let's plug that in. Let's see what happens. This is gonna be interesting. I hope this works. We'll hit F, we see where we want to put it, G, and then of course it does go where we thought it would go. It's really funny though, because weirdly enough, we then can't pick anything else up because we never clear the reference for the held object that we currently have. And the line trace keeps going because it still thinks that we have a valid held object. Not to mention the object appears to be stuck on the floor because of course the midpoint for the object is the center of the cube. So the center of the cube is assuming the intended position on the floor. So we have a couple of little minor adjustments to make here before this system is complete. Let's just first do the most obvious cleanup here, which is we'll just set that variable to be nothing whenever we put down that object. So we're just going to clear that out, and that will help with some things. So for example, now when we try to pick up and drop something, we can actually like pick up something else and drop it, which is a start where before we couldn't do that. So at least we can do that. There is one problem, which is that now that these things get lodged in the floor and they have no collision, we actually can no longer raycast against them a second time because, as you'll notice here, we turned off the collision right here, set actor enable collision, but we never turned it back on again. So that's a problem. So let's copy and paste these nodes. I'm going to put them down here at the end of this code. Actually, I'm going to do that before we clear out the variable since we still, need to access it. Very important. I'm going to put this node right before we clear out the variable so that we're not trying to modify an empty or null variable. We're going to turn that collision back on. So that should allow us to hopefully re-pick up cubes that we place. Let's see if that works. Yes, it does. So now we fixed that bug. We can pick up and place cubes many times. Yay, I love it. Great. Okay, so let's fix some other things. What we actually want to do is we can reuse a scene component here to fix that issue where the object is actually getting placed halfway through the floor. So if we go to this pickup object here, what we're going to do, and we're going to do this for all pickup objects, not just pickup cubes, is we are going to add in a new scene component. And that scene component is going to be floor. Let's call this the bottom of object, actually, just to make it like super clear. I'm going to compile on that. And this scene component is going to be like movable within children. So you'll see if you go to the pickup cube here and you hit compile, all of a sudden you see this bottom of object scene component that shows up. It's been inherited from its parent class. Very useful. So for different types of objects that might come in different shapes and sizes, they all have this bottom of object scene component that we can kind of like move around. So let's go and, you know, we'll just set this to like right here, like yeah, 60. I think that's, no, the cube is 100, so it should be at 50 actually. That's the bottom of the cube. So what we're gonna do now is we are actually going to have the cube be parented to the bottom of the object so that it moves with the bottom of the object in this case. And then what we can do in this controller code is, rather than just setting the world location of the default scene root, we can get the bottom of object and we can set the world location of that. So let's try that and let's see how this works for us. See what we get. So now we're gonna hit F, pick it up. Oh, look at that, the cube. It places so beautifully. And right here, it's placed inside the physics cube. Great. Oh no, it's placed on the other side. Good, I love it. Okay, excellent. So it does guard against that. One other thing you're gonna wanna do if you start using this, this sort of bottom of object component type deal, is that you're gonna wanna make that bottom of object the new default seed root. This will prevent issues where, like, the first time you pick up the object, it does snap to the player correctly, but the second time it doesn't, because the root of the object is not actually the bottom of the object, and so the position of those two scene components becomes slowly desynced over time, meaning your cube is like farther and farther away every time you pick it up, which is like probably not what you want. So just, you can always like, if you see what I did there, I just dragged it on top of the default scene root. And the first time you do that, it'll ask if you want to attach it or make it the new root. You want to make that the new root of the object. And like, then what you'll want to do is go back to elements in the code where like we use the default scene root and just instead get the bottom of object here instead. And what that should hopefully do is it should make some of this stuff more consistent, where like if you try and pick up the cube, it will not go farther and farther away from you every time you try and pick up and drop it, and it will actually snap to the correct position every time. So that's all well and good, but there's one last thing that we need to do before we close out, and that's this. So there's a couple of issues with just using the line trace to figure out where we want to place this object. Issue number one is that debug lines and debug anything in general does not actually cook out when you try and make a build of your game. So if you were to zip up and export your build and try and send it to somebody as a playable game, none of the debug stuff shows up. And that's by intention. It's so that as developers, we can have this stuff turned on to kind of see what's going on in the back end. But the end game user or player shouldn't need to see all this debug stuff. Like, they should actually have some nice visualization there for them that looks better than like a debug line. So that's what we can do here if we would like to build an indicator of where this thing is going to go. The other thing is that because we're now parenting to the bottom of the object, as you'll notice when we pick up cubes now, the pickup location once again is like quite high. So we can fix that a couple of ways. Maybe these cubes are like just really big and you just want to make them smaller. So like you can just make them 0.5 scale size, but you can also go into the pawn and you can look at that attach point. You can bump that down to like the floor if you want and have it just kind of sit super low so that when you pick stuff up, it's not like blocking your view or your ability to see where the on-ground indicator would go. So what we're going to do is we're going to now build like a better on-ground indicator, this kind of blue line. It's very hard to see where in space it is. It's not quite cutting it. It's just a really bad player experience if we're going to extend this code any further. So let's make that a little bit nicer here. And luckily, because we already have all of our raycast math done, we can do that very easily. So in the tutorial pawn, what we're going to do is we're going to create a sphere, and we're going to call this placement loc. Maybe placement loc indicator, just to be super clear that this is like the thing which shows where it's going to get placed. This is a sphere that should have no collision because it's basically UI for the player. It's basically to like just, this sphere will move around with your raycast and show the player, hey, like they're gonna spawn, when you drop this thing, it's gonna drop right here. And let's make it small. So probably like 0.3 is a good scale for this. Oh, why did it get, no, not 3, 0.3. It's turning into a giant egg. 0.3 is good. And we are going to make this sphere invisible by default because we're only going to turn it on when we have something currently picked up. So let's go back into our player controller. And when we pick up an object, we probably want to, at the very end here, we are going to get the active pawn. We are going to get its indicator. And we are going to set visibility on that. Heck yeah, we're going to make it visible when something gets picked up. We'll do the exact same thing when something gets dropped at the very end here. Let's just set that visibility back to false. Make sure that we have our bases covered. So while this placement indicator is visible, what it should do is take the data right here on our tick. Basically, we are drawing that vertical debug line right here. We've got this bit here. And what we're going to do is, instead of like drawing a debug line, let's get rid of that sucker because we already have this line trace to cover for it. At the impact point, we are going to put the placement locator there so that the player can actually see. So we can copy and paste from up here, right here. We're gonna set the world location of that placement indicator. So let's drag off from here, just like this. We're gonna have it teleport. So it has no collision, so this should be fine, but if you don't check teleport, then basically the object actually does move to that location very quickly. So it might trigger some physics interactions along the way if it does have physics. This indicator doesn't have anything. I turned off the collision on it down here already. So we should be good to go, but I'm just covering my bases just kind of out of habit at this point. So let's hit play and let's see what happens here. So we have this little sphere. When we hit F, oh look, now there's like a little nice, like a little indicator. So you see that little sphere goes up on top right there. And if I hit G, I can see that I'm gonna drop off my cube there. Isn't that nice? It looks like when we shrank the cube, we actually like maybe messed up some of the some of the orientation around it. So let's look at this. Let's look at our cube again and see what I did. It looks like the cube may have gotten lifted off the floor slightly. So let's fix that. I'm gonna just bump him like that. And oh no, now they're actually placed off of the floor. That's what's going on. I didn't put him on the floor. So it looks like actually his bottom of floor indicator is like too low for him. So maybe what I'm gonna do is just put him halfway through the floor to compensate so that he looks like he's at the appropriate height. It's a little bit of a hack, but basically if the bottom of the floor indicator is actually at the center of the object now, then the center of the object should be halfway through the floor. That's how we do that math. It's very janky, but it works. So now we have this indicator that actually shows where and how that object is going to be placed. And that also might show us, you know, looking at it, like maybe, just to be totally honest, it's a little bit far out. You know, like that's a very long way. We probably really want it where I'm aiming my reticle right now, like kind of right here. So what that then says to me is I can actually adjust all of these numbers on the fly. I can go back here and when I do this line trace for objects, maybe I don't want the distance to be quite so long. So maybe I'll cut that in half. And maybe even if I'm being super smart, I can variabilize that and say distance from player to drop objects, make that a local variable of type float, and I can actually have this get plugged in and then set the, when I compile, I can actually set a default value for that of 500. And what that lets me do is if somebody else were to look at my code, they would know that all they would need to do would be to change this variable to change how far that indicator actually goes. So let's see. That's a lot better actually. I like that quite a bit more. So, and you'll see now I can actually even place cubes on top of each other. I can make a little cube snowman. It's pretty janky, like for sure. Minecraft is not going to be calling me anytime soon to ask me to write code for them, but hey, we've created a simple little pick up and drop system. And there are a number of different ways that we could expand this, but the foundation of it is all using raycasts. So as you can see, Raycast can be extremely useful and flexible for a wide variety of applications. They're also a little bit tricky to implement. So when you are working with Raycast, I do recommend having that debug line functionality on as often as you can, just to try and see if what you think you're doing in terms of the vector math is actually what you're doing to the Raycast in reality. As always, if you would like to extend anything we learned today and try a little bit of a homework assignment, I will put some options in the comments below, and if others have suggestions, I will also add them into the video description. Just make sure to check that out before you go and see if there's anything that looks interesting there for you to try to expand what you learned today. Next time, we are going to be building off of what we did today, and we are going to be learning about the magical world of UI in Unreal 4. That is putting buttons on screen and otherwise allowing you to build very, very simple panels and things like that. As always, thank you for being with me, and thanks for hanging out. I hope you learned something today. I hope you have a lovely rest of your week, and I'll see you next time. Take care.